we're referring to predicting and understanding the real world behavior of battery design from all the way from the start all the way to the end. There is no all-in-one solution set. And there are barely any solutions available for battery simulations, and those that are available are disconnected over the entire process. Another big challenge is the dependency on costly and time-consuming prototype-driven design and physical qualification tests for thermal validation of components. Now, we know that physical testing stifles the ability to explore many design variants in development and essentially becomes a barrier to innovation. Another common challenge is setting up the simulation for thermal validation of battery packs and electronic systems, which contain thousands of parts, which is time-consuming, difficult, and error-prone. Essentially, today we will look into the Siemens solution that streamlines the design of a battery virtually from cell microstructure to a single cell design to cells in a battery pack and batteries in full systems, while using simulation to reach your optimum design based on your objectives and constraints. Let's have a look at the engineering process for battery design and the Siemens solution offering. So the solutions available are capable to analyze a wide range of length scales, and this is perfectly appropriate as studying and designing batteries is a multi-scale problem. We're going to start small and move up from there. So our software portfolio can start all the way with studying the microstructure electrochemistry. The engineer here can study in 3D the effect of the electrode morphology on the electrochemical performance. Now, this tool is addressed to material manufacturers and cell designers. Then moving on to the cell level. Our solutions have the unique capability on the market to allow the cell designer to build a digital twin of the cell by configuring with high fidelity each component of the cell design. Now, this design can be coupled to performance models to test virtually the cell in various conditions like dry cycles, pulses, etc. Now, to study packs and modules, let's move to the next level. That is, build and analyze the complexity of the pack and its thermal management system. What's key over here is we're able to leverage our cell design in the previous step and build packs in a streamlined workflow with a few clicks. This process is generally tedious when setting up batteries with hundreds and thousands of cells. Here, we can analyze thermal behavior while understanding the highly coupled behavior of the pack's electrical performance and the surrounding environment. Now, finally, to the study of a full system. Co-simulation between system simulation tools introduced in the last session can bring even more realism in actual drive cycles applied to the pack. Essentially, we can bring a full breadth of solutions within the battery modeling solution process today. But for today's presentation, we're just going to focus on these 3 sections. That's the virtual cell design and test, the battery pack, and the system design. And the reason, because what we have seen and what I've seen with most of our customers, this is where their interest lies in. Generally, a lot of the customers would buy their cells from third-party suppliers. So before I jump into tool set, I would like to go through some success stories that Maya has had in the battery space. First and foremost, Lion Electric Company.